In this video, we are going to implement the Prim's algorithm in C++. Now, in the previous tutorial, we have already covered the Prim's algorithm and we have seen how actually it works. So, if you haven't seen that video, I will suggest you to watch that first because we are going to take a lot of reference from that video. So, I will drop the link to that video in the description below, or you will be able to see an I button here, and if you will click on it, you will be able to watch that video. So let's start with the implementation of Prim's algorithm, and what I've done is I've already created the algorithm here, and I will explain you what this algorithm is. So the output that comes from after implementing this whole program will look like this. Now you can see that the output contains the edge and the weight. So edge is basically the edge of the minimum spanning tree. So if we have a graph and we are going to give the graph in this Prim's algorithm implementation, it is going to give an output with some edges and some weights here, which you can see here. So these edges and weights, when you will analyze them, you will be able to know that these are actually this is actually a minimum spanning tree. So the output will give us a minimum spanning tree, which is actually the minimum cost spanning tree. So let me just first show you this. So you can see here in the previous tutorial we discussed this graph. We saw how we can run the algorithm, how the approach should be. So I've converted this whole graph in the adjacency matrix. So the step one, and I'm going to show you the whole working of this algorithm, the whole implementation step by step. So make sure you watch this video till the end, because if you will miss any step, you will probably not be able to implement this algorithm. So now I've created in the step one, you can see here, if you will, let me just scroll down here, you can see here I've created a graph, and this graph is, let me zoom in. So this is a graph which I've created, which is essentially a multi-dimensional array, and what you can see here, I have initialized it with these values. So I've created a graph, and you can see its size is 5 by 5 because we have initialized v as 5. So now what I'm going to do here is, now you can see here I have created a matrix. Now let's come to the step 2. Let's come to step 2. In the step 2, we are going to initialize an array which will have the number of vertices locations. So in this case, you can see we have 5 vertices. So we are going to create an array with 5 locations from 0, 1, 2, 3, 4. And we are going to initialize this whole array. This is actually the visited array, which maintains a record of which vertex you have actually visited. So we will initialize it with false initially, with false. So all of these values will be false initially, and same will happen with this one. So we know that we will have to start from this position, which is the 0th vertex. So after initializing this, we are going to initialize the 0th value as true, because we are going to start our whole program from this vertex. So it will change the value of this to true. So you can also see that from here. So you can see here I've created a visited array, and this is actually the array that we have created, and you can see this function. This is a memset function, and this memset function takes 3 arguments. One is the array, second is the value that you wish to set in the whole array, and initially, since we will have to initialize with false, we have written false here, and you will have to use the size of function to give the size of this array. So this is how we're going to actually create an array and initialize it with the false value. this is a very useful function memset, and the header file corresponding to it is C string. So now let's move on to the next step, which we see here. Here we are going to just print in the output screen the edge and weight of the minimum spanning tree that we wish to enter. Now let's move on to the next step, which is our step 3. So let's study the step 3. Now step 3 says that the number of edges, we know that the number of edges in a minimum spanning tree will be equal to this value, which is number of vertices minus 1. So in this case, since we have 5 vertices, the number of edges will be 4. So now we are going to run a while loop which will run 4 times, it will run 4 times, and at every time it is going to run the algorithm on each and every edge. So we are going to create a while loop. You can see here I have created a while loop here. We will first initialize the number of edges as 0, and then what we are going to do is we are going to write this condition: number of edges should be less than vertices minus 1, which comes from the definition of minimum spanning tree. We know that. Now what I am going to do is I'm going to create a variable which is min variable, and what this min variable does, whenever you are going to visit a particular vertex, you are going to see which is the minimum edge corresponding to it. So let's suppose here we are visiting 0 first. So you can see there are 3 edges here which goes from 0, and you can observe that this should be the minimum value. So we are going to run the algorithm in such a manner that it will point the minimum value as 2. So what is the strategy that we are going to use? We will discuss it later on in this after we will move on to the step 4, but at this point we just need to know that what is the use of this min variable. It holds the minimum value or the minimum weight of the edge. And let's move on to another initialization step. You can see here I have created 2 values, R and C. Now what is the use of R and C? Now R is the row index and C is the column index of the edge which we want to display in the minimum spanning tree output. So if we carefully take a look at the minimum spanning tree in the console, you can see here that this is the edge, and this value 0, 4, 3, 1 are the values of the row index, and this value is going to be the index of the column. So it is actually C, and we will see that later on in this program only how that is actually achieved. So now let's move on to the main algorithm which lies here in this section of this program. So let's see what this algorithm does. So the first thing that I'm going to do here is I'm going to write the step 4. Alright, so in the step 4 we are going to create 2 for loops which will run which will scan this whole matrix. So we are going to create nested for loops. One for loop will go here, and there will be another for loop inside this for loop. Now these 2 for loops are basically used to traverse to every position in this matrix. So since it is a multi-dimensional array, we will have to use 2 for loops, and they both run from the 0 position to the 4th position. So I'm going to write here 0 to 4. So you can see here I have created a for loop here. So this for loop actually traverses along the row to pick up every vertex, and you can see here I have created another loop that runs from 0 to 4, and it actually traverses along the column. So in this matrix we are going to I is going to traverse along this one. So I'm going to write here I, and J is actually going to run this way. So in this manner we are actually scanning the whole this whole matrix. And let's move on to the next step, which is the step 5. And step 5 is this condition. So now whenever we are at any particular row, we are going to see that in the visited array what is the value of that particular vertex. So let's say initially we are at the 0th vertex, so the value, we have also initialized the value in the visited array of this particular vertex as true. So what will happen is, in the if case when we are going to ask what is the value at the ith position, so I is equals to 0 in the first iteration. So I'm going to write here I equals to 0. So I will replace here at this position, and we know that this position equals to 0, so it is true. So if it is true, then only it is going to proceed with the algorithm. So we know that we will have to only traverse along this row only for the vertex that we are actually visiting, and not all of them. So in the first iteration, since we are visiting only 0th row, we are going to mark the visited array of 0 as true, and for the rest of these positions we are not going to run our algorithm. So after this for loop, after this step 5, after this condition, now we are going to enter in this step where we are going to traverse along the columns. So here is a for loop which traverses along the columns. So we know that first we have picked this vertex 0. So the while loop will run only, the for loop will run only at this position, because all of these are false, and this is actually because of this if condition here, which you can see. So now we're going to, since now we have entered in this if statement, now we are going to traverse along only this particular row. And this makes sense, because whenever we are visiting an array, we are only concerned about the edges that are connected directly to this array. So now you can see here that we are going through this, we are actually creating a for loop to visit through this whole array. Now our task was to actually find out which is the minimum value in this whole row. So you can see here that 2 is the minimum value, but since we do not know that at this point, let's see what is the algorithm for finding the minimum value of a particular row. And remember that the particular row represents all the edges that are connecting to this vertex that we have picked in the visited array. So here you can see I have written an if statement which says that if the value of min is greater than the value at the j position, then only we are going to proceed with the algorithm. So let's see what this means. Now initially I have assigned the value of min, so I'm going to write here step 5. So initially I have assigned the value of min as high, and high is a very big value, which you can see here. I have assigned the value of min as high in this line, and high is actually defined here. It is a macro, and the value of high is actually so much big. It's 99999. So what we're going to do is we are going to compare the we are at this step, and this is actually the step 5. So I'm going to write here step 5. So now we are at step 5, and we are going to compare the value of minimum with the value of this position. So when we will reach this step, what is the value of minimum? The value of minimum is equal to the high value, which was 6 times. Now we are going to compare this value with the g of I comma j position. So what was the we are now currently at the 0th vertex, so value of I is 0. Now since we are going to consider this j position, now we are concerned with the j position, it will start from 0 and it will end till 4. So let's say we are at this iteration, which is at the 0th position. So g 0 comma 0. Now we are going to compare this value with this one. So now you can see that the value at g 0 comma 0 position is 0, and this is actually, this value minimum is greater than this. So this will allow us to go into to proceed with the algorithm. Now what we are going to do is, when we are going to proceed with the algorithm, you can see here we are directed to this step, which is the step 6, and although I have not discussed how we will be able to find this minimum value, we will see in this case that how we can actually change the value of minimum to the actual minimum edge weight. So let's move on to the step, which is the step 6. Now in this step you can see I have written two conditions here. Both of them has to be true for this algorithm to work, for this whole code to work. So one is that the value at the I comma j position should not be equal to 0, because if it is 0 we are not concerned with that. So you can see here, whenever we are reaching at any position which includes 0, we are not going to proceed with the algorithm. We are going to stop at that iteration. So this is the meaning of this one. And if you will see this condition says not equal to v array comma j. So what will happen is, if the value what is the value of v array j at this iteration? So at this iteration, the value of v array, the value of j is equals to 0. So what is the value of v array? 0. V array 0 is true. So since this is true and this is false, it is going to it will not run, because initially it was 0. So this will give me false and this will give me true. So true and false, and is the condition, is the operator between these two. Alright, so let's see what will happen in the next iteration. So in the next iteration, the value of j will get incremented to 1, and you can see that this if case which we have written, this whole if case is there because we actually want to see, we are not concerned with the values that are 0. So that's why we are taking this value, and we are using not equal to v array, because whenever we are visiting, we have seen an important point in the previous tutorial also, that if we have visited a particular vertex, we are not going to consider the edge that is connected to it. So that's why we written here not equal to v array 0. So now you can see here that this was the actual value of j, so it will get incremented to 1. So the value at v array 1 was equal to false, and since there is a not operator here, it will make this value as true. So it will not make this true, it will remain false, it will just check. So this expression will give me a value true, so I'm going to write t here. And what is the value at g? 0. And now since j has incremented to 1, we are at this position. So the value at g 0 comma 1 position is 4. So since it is not 0, it is also true. So now we are going to enter into the algorithm, which is here. So you can see after this iteration, when j is equals to 2, this will give me true. So once this is true, what we are going to do is we are going to change the value of minimum equal to this value, which is gij. So let's change the value of minimum and the value of RNC. So here you can see after the first iteration, the value of minimum will now point to 4. So you can see this is the value 4, so the value of minimum will be 4. So now we are going to see what are the values of r and j. Now r will be equal to I, so I was equal to 0 and j was equal to j was equal to j, so which is 1 in this case since it has been incremented. So this should be actually c. So the values of r and c are 0 and 1. Now we are going to take a look at the second position, and again we are going to consider this case, this one, and again we have seen that this is the value 0 coming here, so it will make this whole condition false, so we are not going to consider that. Now the value of j will get incremented to 3. So now the value of j will be equal to 3. So now let's compare this minimum value because it has changed. We will compare it with this value, the value at this position. So the value of min is equals to 4 and the value at I was 0 and the j was equal to 3. So now we are going to compare these two values according to this case, which is this one, and let me show you here. This case is here. So this case is actually used for comparing the value of min to each and every value of the row that we are concerned with. So whenever we will find a value which is less than the minimum value, then only we are going to assign that value with the minimum value, else we are not going to do that. So now you can see that the minimum was equal to 4 and 4 greater than 5 is actually will give us false. So this means that we are not going to change the value of minimum r and c in this case. So now what we are going to do, we are going to increment the value of j by 1. So j is now going to point at 4. So we are going to change the values of minimum r and c only when we have find out the value of minimum is less than the value at the gi comma j position. So now you can see the j has incremented here to 2. So now what we are going to do here is we are going to assign the value of minimum as 2, because the value of minimum was 4 initially and this value is 2, and since this condition will give us 2 is less than 4, this will give us true. Then we are going to assign the values of min, r and c. So the value of min will become equal to 2, the value of r will be equal to 0, and the value of c will be equal to 4. So we know that now after the whole iteration has ended, now we have these values with us. The value of minimum is 2 and the value of r is this and the value of c is this. So now we have find out the minimum vertex that which is 0 to 4. You can see we have got the positions 0 to 4 and we have also got the weight of this whole edge. So this edge is going to be a part of the minimum spanning tree. Now we know that whenever we have find out an edge, now what we are going to do is we are going to assign we are going to move our we are going to point to the next position, because we will have to calculate the edge from this position, not 1. So what we are going to do is we are going to assign the v array, and since this is actually equal to c, you can see here it is c, this is c and this is r. After first iteration we are going to assign the v array of c as true. So this means that c was equal to 4, so this value, this will not be false, this will now become equal to true. And now our for loop is going to point to this row, and we are again going to follow the same mechanism, the same algorithm. We are going to check that and then again we are going to find the minimum value, and in this manner we will be able to create a whole minimum spanning tree with number of edges as v minus 1, because there is a while loop here. So you can see here after this loop what we are going to do is we have got the values of r and c, and we also know the minimum value which is grc. At this position we have got the minimum value and we are going to display that in the output, and after that we are going to assign the value at the c position of the visited array as 2, because now we are going to visit that position, because we are going to traverse to that row only, which you can see it is 4 in this case. And we are going to perform this algorithm, and number of edges will be incremented by 1 after every iteration, and it will run 4 times, and every time it will be able to find out the whole minimum spanning tree. So the output that you will get by running this program will be here. It will be like this. So this program is also available in the Android application that I have developed. So that's all for this tutorial. Thanks for watching.